Can you all guess which is the important part of the computer that stores the operating system, large files, images? Guess. Yes, it is the hard disk. So, me and my mates will brief you on the storage of the data in the hard disk. Before that, let me introduce myself. Hello everyone, I'm Sania Kausar. Along with me, I have...
Hi guys, this is Pooja.
First, let us know what is a hard disk. A hard disk is an electromechanical data storage device which stores and retrieves the data using magnetic storage. Explaining in a very simple words, that is, the hard disk is the data storage which stores the information in the form of binary numbers or the digital form, that is zeros and ones. The part of the hard disk that stores the data is known as platter. Platter is circular, non-magnetic with thin layer of aluminium alloy, glass or ceramics, which is further separated to tracks and sectors and has two motors, one is spindle and one actuator. Let's look through a short video of opening a hard disk. As our mobile phones store lots of data in it, similarly, the hard disk in computers store the files of games, images, music, documents, etc.
The hard disk was first developed by IBM in the year 1956. It was first named as IBM 35D Disk Storage Unit. The platters in the hard disk consist of several sectors which consist of zeros and ones. Some of the parts of the hard disk are spindle, read-write head, actuator, armature and selenite board. The platter rotates up to 10,000 revolutions per unit. There are two types of read and write heads in the platter, in each of the platter. One for the top surface and another for the bottom surface. Let's consider the hard disk has 5 platters, then it needs 10 read and write heads. All might be wondering, how does it store so much of information in such a small space? So basically, the platter consists of ice spinning wheels which has magnetized metal grains. Hence, the information is recorded in magnetic patterns as the tiny grains of bits which are being aligned with one or two possible states. That corresponds to zeros and ones. Data is written onto the disk by converting string of bits into electrical current through an electromagnet, which generates the strong field that is enough to change the direction of metal grain. Once the information is written onto the disk, the drive must use magnetic reader to turn it back into useful form.
But still you might think, how will so much of information will be stored in zeros and ones? Much like giving an example, capital A coded has 0, 1, 0, 0, 0, 0, 0, 1 and small a has 0, 1, 1, 0, 0, 0, 1. Similarly, the letter has coded in 1 bytes or 8 bits, where a single photo takes several megabytes and it is stored in our hard disk. As it was explained before, to write the data on hard disk, a magnetic field is placed in a thin field in one of the two polarities, South Pole and North Pole. If North Pole arrives before the South Pole and if South Pole arrives before the North Pole, the orientation takes place in one direction, like North-South represents 1, while other orientation South-North represents 0. Basically, this is the structure of disk showing tracks and sectors. Each track is divided into number of sectors and the information stored there. Your computer stores data on its hard drive. The data is stored in very orderly pattern on each platter. Subdata arranged in concentric circular path called tracks. Track is broken into smaller areas called sector. Parts of hard drive stores a map of sector have already been used up, other are still free. When computer wants to store new information, takes a look at the map in some free sector. It instructs the read and write head to move across the platter exactly the right location and stores the data there. To read the information, the same process runs in reverse.
From the past 7 decades, the exponential growth in the computer storage capacity and the processing power followed the patterns of Moore's law. That is, the information density would double every 2 years, and thermal expansion control of the head allowed it to fly less than 5 nanometer above the disk surface and above the width of 2 strands of DNA. Earlier hard disk drive wrote the data in sum of constant bit per second, resulting in all the tracks having the same amount of data per track. But in modern drives, we use zone bit recording. It increases the writing speed from inner to outer zone and thereby storing more data per track in the outer zone. In modern drives, the small size of a magnetic region creates the danger that its magnetic state might be lost because of thermal effect. Thermally induces magnetic instability, which is commonly known as superparamagnetic limit.
Next is hard disk failure. So failures occurs in hard disk, that is electrical failure, firmware failure, multiple unknown failure, mechanical failure, logical failure, bad sector failure. First is electrical failure. For example, a power voltage damages a hard disk electronic circuit, causing a read or write head or circuit board to fail. If the hard disk power is on but can't read and write the data or boot, it is likely that one or more of its components has suffered an electrical failure. Next is firmware failure. It happens when the software that performs the maintenance task on the drive and enables the hard disk to communicate with the computer becomes corrupted or stop working properly. This type of failure can lead to the disk freezing during boot up or the computer a hard disk is connected to not recognizing or misidentify it. Third one is multiple unknown failure that accumulates over the time can also occur. For example, an electrical problem could lead to a mechanical failure such as a read or write head crash. It might also lead to a logical failure resulting in several bad sectors developing on the hard disk platters.
We hope the concepts explained by us were understandable. Thank you for watching.